Good evening. Today we'll be going over a final project microphone created by myself, Alejandro Llorente, William Cruz, and Diego Sanchez Del Rio. So, the justification for this microphone. Our main objective for this project was to create a less expensive microphone with the same performance capabilities. The purpose of this microphone is to create a cheaper alternative with the same performance capabilities for a fraction of the price. Our objective here was to gain parts for a fraction of the price compared to the microphones in today's open market. Then, using said parts, we would connect it to our MagDAC voltage source as well as our circuit board, and putting everything together, when the microphone receives a voice signal, the oscilloscope should receive an audio output. The output would reflect the same performance as if it were an expensive microphone.
So, to understand a little bit about the background of how we were able to do this experiment or project, we had several sources. One of them being Andre Gabriel, who was able to direct us, and who was an engineer who was able to direct us in helping build this microphone. And the purpose of this experiment was to prove that we can make an actual cheaper microphone with these materials, as Alejandro was also stating. And so the prototype, we're going to get into the prototype. As you can see, we have a clear image here of the prototype. And just to describe a little bit, this is where we have our DC MyDAC voltage source going into the drain leg of the transistor, and the microphone source soldered to the gate leg of the transistor. The source leg of the transistor outputting to a resistor of 2.2 kilo ohms and a capacitor of 10 microfarads in parallel, in which the resistor is then connected to ground and capacitor is connected to the oscilloscope input, giving the following output, which our friend Diego is going to explain a little bit more on.
This is our working prototype for our microphone project. We're currently using the MagDAC instrument to both power the entire circuit and receive the output from the microphone capsule into the oscilloscope. And then we're also using the MagDAC to provide a ground voltage source for our circuit. This is the MagDAC oscilloscope, and this is the live running of the microphone. As you can see, it is showing and reacting to my sound stimulus, and it's showing a healthy sine wave, showing that there is an actual AC output to this circuit, which is what we're looking for. The reason why the output is such a low voltage is because by default the audio capsule will output an extremely low voltage, and we had to use a transistor to use as a preamplification component so that it would even register on the oscilloscope. Otherwise it would not register, and the oscilloscope would have to be set to a much finer and much more not inaccurate, but less precise measurement. Okay. Thank you for watching our demonstration.